Welcome to Tammy's Maths. We have a miscellaneous collection today. Let t be the tangent to the parabola y square equal to 16x at the point 6432. Let L be the tangent to the same parabola at another point x1 y1 on the parabola, x1 y1 on the parabola. If L and T are perpendicular to each other, then the distance between x1, y1 and the focus of the parabola. Let's see. T is a tangent to the parabola at the point 6432. L is a tangent to the same parabola at another point x1, y1 on the parabola. x1, y1 lies on the parabola. If L and T are perpendicular to each other, then the distance between x1, y1 and focus of the parabola. Some choices given: 15 by 4, 4, 17 by 4, 5. Before I could start the question, let's go in for the basic fundamental. I always insist on the fundamentals, and the importance of fundamentals we do know. Now, what is a conic section? There is a fixed point and there is a fixed line. Points are moving such that the distance from the fixed point to the fixed line, the ratio, always remains a constant. That curve will be the conic section. And we have three curves under that: parabola, ellipse and hyperbola. That fixed ratio is called the eccentricity. If eccentricity is 1, we get the parabola. If eccentricity is less than 1, we get ellipse. Greater than 1, we get the hyperbola. It's full of properties. Now, let me have the parabola y square equal to 4ax. This is the focus. The fixed point will be called the focus. Focus of this will be A0. And we have the directrix, that's a fixed line, and that is x equal to minus a. Now take any point P on that parabola. This is called the focal distance. This is called the focal distance. Like on a circle, you have no distance from a point on the circle to the center, that will be the radius. Of course, that's a constant there. Here, not that. Take a point on the curve. The distance from the focus to that will definitely vary. It can't be same. That is called the focal distance. That is called the focal distance. Now, let this point be x and y. By definition of the parabola, SP by PM should be a constant. That constant is called the eccentricity, and that eccentricity will be 1 here. So SP will be equal to PM. Now, drop a perpendicular here. This is x, because this point is xy now, and this is A. This is vertex, this is A. So this distance is x plus A. This is the origin actually. This is the origin actually. This is the line x equal to minus A. Origin is the vertex. So this distance is x, this is A. So SP will be x plus A. So what will be the focus distance of any point on the parabola? It will be x plus A. For any point, what is x? The x coordinate at that point. And what is A? A, y square equal to 4ax, no? That A will be, let's focus, the x coordinate of the focus. Okay? So the curve we have y square equal to 4ax. This is the vertex 0, 0. And this is a line directrix which is x equal to minus. This is the origin actually. This is the origin. And take any point P here. This is the focus A0. By definition of the parabola, SP should be equal to PM. Now drop a perpendicular. This will be x and this distance is A. So this distance will be x plus A. So SP will be x plus A. Okay. Now, we have the parabola y square equal to 16x. y square is equal to 16x. So y square is equal to 4 into 4x. A is 4. Now, T be the tangent to the parabola at 6432. T. L be the tangent to the same parabola this is L at the point x1, y1. They are perpendicular to each other. This is 90. What is the focal distance of x1, y1? That's what we have to find out. So this is the focus. We have to find out the focal distance. You can do in many ways you like. Now the point is 6432. Y square is 16x. Differentiate. 2y into dy by dx is 16. The slope at the point 6432 dy by dx is 16 by 2y. Y is 32. That is 1 by 4. So slope of this line is 1 by 4 slope. These two lines are perpendicular to each other. Therefore, the slopes will be negative reciprocal of each other. So, slope of this line L will be minus 4. Keep that to yourself. Now, x1, y1. What is the parametric representation of that? A square 2at. For the parabola, y square equal to 4ax. Substitute and check. 2at. 4a square t square, and x is at square, 4a at square. For every t it will be satisfied, so t will be the parameter for this. Now, let this point x1, y1 be at square and 2at. So y is 2at and x is at square. Dy by dx, we have to find out. Let me go in for dy by dt, that is 2a. Dx by dt, dx by dt is a, 2a. A and this is 2t. Dy by dx will be 1 divided by the other. Dy by dx will be 1 by t. So slope of this is 1 by t. What is 1 by t equal to? Minus 4. 1 by t is equal to minus 4. So what is t equal to? 1 by minus 4. What is the x coordinate here? At square. X coordinate is at square. That is x1 is at square in the term of parametric form. What is a? 4. And what is t square? 1 by 16. So x coordinate is 1 by 4. What did I tell you just a few minutes back? The focal distance is x plus a. X is 1 by 4 and a is 4, which is 17 by 4. Do we have it? This is a very recent question, this year's question. 17 by 4 will be the focal distance. You can try other methods also if you want, it will work. But try to choose methods which will take you fast to the answers. So this will be the answer for that. So we will meet in the next video with more questions.